And we're going to teach you a method for graphing that is called the framing method. So each time we create a graph, we're going to construct a frame for the graph. And that's really nice because we can look like at some critical points of the graphs where they hit the maximum, where they hit the midline of the graph, where they hit the minimum. And we can kind of mark those points for sines and cosines within that frame. We can label some points. Probably the one thing about framing method that becomes a little bit difficult is generally we tend to make our frames like the same rectangular size every time. And so by doing that and just kind of labeling it out in that same size rectangle is we kind of lose out on the stretch and the shrink of the period. We're not going to see like really stretched out waves or really scrunched waves because we're always going to put it in the same size frame, but it's going to be different labels. So I'll try to make comments about that, like think about what happened to your period. Would that be like that slinky that you'd be scrunching together so the waves happen more often? Or would that, when you like extend your period, make it more than 2 pi? Is that an example where you pull your slinky out and the waves are more gradual? Okay, so that's one thing that's kind of like should be going on in your head, because if you graph them in your calculators, then the graphs might look a little bit different in terms of actual waves because of where the frame is. Note that graphing, the sine and the cosine graphs, will be on no calculator portion of your test. So even though you can graph them in your calculator, and I think it's great if you do that, just kind of see what that looks like. You need to be prepared for the test to go without. This you should really have in your notes from yesterday, so I'm just going to reiterate. This is the sine graph here. And we talked about yesterday how we could create the sine graph using a table of values with the unit circle. And so these are some points that showed up on our sine graph where the x-coordinate is the angle and then the y-coordinate is the value of sine at that particular angle. So hopefully you had drawn those in your notes yesterday. If you didn't, it's not a bad idea to go back to like the hard copy notes that I have posted online, either for today or from yesterday, and make sure you know those 5 critical points on like what I would call the parent graph of sine. Okay, and we also talked about yesterday, just really quickly, the domain for the sine function was going to be all real numbers because it's that smooth curved wave with no starts or stops, and the range was -1 to +1. Similarly, we talked about cosine yesterday using the unit circle, and we marked some special points, 0, 1, pi over 2, 0. The difference here is these are now, the x-coordinate is the angle, and the y-coordinate, instead of being the sine value, because we're doing the cosine function, is now our cosine value on the unit circle at that particular angle. Okay, so again, these things are probably already in your notes from yesterday. I don't think you necessarily have to redraw them, but we're making connections because these are what we would consider our parent graphs. Okay. So all the transformations that we look at in our framing method are transformations of these graphs. So the next piece is going to be the framing method, and I have a piece of paper that we will add into our notes. So I'm going to pass this out to you, and then I'll pass around the tape dispenser. Maybe just take a couple pieces of tape and tape it into your notebook. And so again, framing method is just a method to create the graphs of the trig functions. It is not necessarily the only way that you can create that graph, but it's a really nice way that works for a lot of us to get, 5 points so we can get a full period on a graph. Okay. So here's how the framing method works, and this is not on that sheet of paper that I have passed out to you. But there is a frame. So you see that rectangle on the screen right now? You have already practiced yesterday in your notebook getting some important information that we're going to need to construct the rectangle. Okay, one of those things is the starting point. Okay, so you practiced yesterday figuring that like horizontal and vertical shift and coming up with a starting point, C over B comma D. An important note to make now today is that is the starting point for the frame. That is not necessarily the starting point for your graph. Okay, so that's the starting point for the frame, not necessarily the starting point for the graph. If you think back to sine and cosine, and we're going to fill this in on those four rectangles momentarily, but sine starts at the midline of what we would consider like the frame, the rectangle that we're going to house our trig function in. And even if I did a reflection, you know, sine would start at that same 0, 0 point. So the starting point for your frame is the starting point for a sine function. But if you think about our other function that we're going to be graphing, which is cosine, the starting point for the frame is that 0, 0 point, which is not actually on the graph. So you'll have to be aware of that whenever you're graphing cosine. Where you start your frame is not necessarily a point on the graph, so you don't necessarily have to draw a curve through that point. Okay? So cosine will either start at the very top corner of your rectangle for your frame or the bottom corner if you had a reflection. Okay? And we're going to show that in the rectangles on the blue piece of paper momentarily. Okay. The other things that you did yesterday that are going to be helpful for the frame is you identified amplitude. Remember that amplitude is half of the distance from the lowest to the highest point. So you see me here on my starting point. I've got to put an amplitude above and an amplitude below so that the distance from my minimum to my maximum is twice the amplitude, because the amplitude is half that distance. Okay. And the other thing that you found yesterday that's going to be super helpful is the period. So what you're going to see is basically one period of sine or cosine, okay, where it runs through its wave. And then that period you can just pick up and copy and paste before and after, and we have that smooth curve graph. Okay. Now, what's really nice about the framing method is we're going to take the period, and you'll have like your starting point, and then you'll figure like how far your period is, what's your distance. So you'll add that distance on. And then you'll be able to mark these points in the middle. This, of course, is going to be half the distance of the period. Okay? And then the other two are quarters, so half of a half. Okay, but just let me kind of talk about that as we're like labeling things, because we want to label these sections right here at the bottom in terms of pi, in terms of the angle, so that we can then label the 5 points. This will provide our x coordinate, okay, and the amplitude will help us with our y coordinate. So, in the framing method, okay, and this is on your blue sheet, kind of gives you some steps. So if you just kind of look at the very top, it's got the general form there, okay, y equals a times sine of bx minus c, and then plus d. And then below it, it's got a list of steps, like identify A, B, C, and D. Find the amplitude, find the period, identify any translations, and your starting point. Okay? So those are things that you practiced yesterday. Step 2, identify the starting point using the horizontal and vertical shifts. That's your C over B comma D. And then there's that note there that says this is the starting point for your frame, not the graph. So if you have a highlighter and you want to highlight that, underline it, box it, circle it, that's a really important note for a lot of us. The starting point is the starting point for the frame, not the graph. Okay. Next one says construct the frame, starting at the starting point. Use the amplitude to determine the top and the bottom. So you'll just add the amplitude and subtract the amplitude from the y value of your starting point. Use the period to determine the length. So you'll add that on to the x coordinate of your starting point. And then we'll plot the 5 critical points and label them and sketch our graph. So you have 4 graphs down at the bottom. And what I'd like you to do is like go ahead and cut your rectangles in these like 8 equal sections. So what I would do is I would go from the starting point, I would make one horizontal line across, and then I would cut the rectangle in half, and then I would cut each of those halves in halves again. So construct in each of those boxes, those 8 similar sized boxes. Can you draw that 8 boxes? And then off on the left side at that midline, you might mark that point. This is the starting point, so I'm going to label it SP for starting point, starting point, starting point, starting point. But remember, that's the starting point just for the frame, so you know where to add and subtract your amplitude and then go for your period. That doesn't necessarily mean that's where your graph is going to start. And then the next thing that we're going to do is plot, like if it's a sine with a positive a value, where will your 5 critical points be in the frame? Well, they're the same critical points that are on that sine graph that you graphed yesterday. So you'll have, it would start at normally 0, 0, but that might not be 0, 0 anymore because of shifting. And then you would go up, back to the midline, down, back to the midline. And those would be where your 5 critical points are. I mentioned to a few classes yesterday when I learned how to graph trig functions in high school, my teacher always said for sine, you remembered mountain high, valley low. So you started in the middle, you drew a mountain, you drew a valley. And that was how I knew what my shape was going to be. Okay. If you have sine with a negative a, that is going to be reflected. So you're going to start at that midline, 0, 0. So the starting point for sine frame is actually a point on the graph. But this time you're going to go low, midline, high, midline. And get that nice smooth curve. And then for cosine, again, thinking about that graph that we did yesterday, we talked about how sine always started at 0, 0 on the unit circle, but cosine would start at 0, 1. So it starts at the high point, midline, minimum, midline, maximum. And, you know, these should be like wave shapes, so you don't just want to draw a V. Okay, sort of get that like mountain-esque piece. Coming down. And then cosine with a negative a, again, would just be a reflection in the x-axis, which will end up being a reflection over that midline for the graph before the transformation. So instead of starting at 0, 1, you're starting at 0, negative 1. Of course, if your starting point is not at 0, 0, that would be a different value. And your maximum happens in the middle of your frame. So you can use this and these 4 pictures to kind of help you, like these are the 4 graphs we should really see within our frames. The other key piece to us being able to graph and identify things like domain and range is going to be, do we label things correctly in terms of the starting point and the amplitude in the period. Note that, again, I would say generally you can get into a mode where you're always drawing the same size rectangle for your frame. So even though like one might have a period of 2 pi and the other one has a period of pi over 4, they're going to look exactly the same, even though we know that one with period of pi over 4 would be doing a lot more waves in that same space. Anybody need more time getting those down? Okay, so this is just kind of a rundown of how you work the framing method. You can write these things down if you want. They're very similar to the steps that are on the blue sheet, so if you choose not to copy down these things, that's also okay with me. The blue sheet, I should say, I just forgot, it has tangent on the back, which we did not mean for it to have. So I'll give you a different sheet on the day we do tangent, which will be next Monday. So you can like take this down. You don't need the back of that. Sorry. That's a miscopy. Okay, so here's what we're going to do in the next examples. We are going to, I would say, do the same work as yesterday. We're going to identify amplitude, period, and starting point. And we're going to start by plotting the starting point. We're going to construct the frame from the starting point. So that starting point is always that point in the middle on the left side. Your amplitude is going to be your height, okay? But you're going to have to add it on top and then also subtract it on bottom. Okay, so your height is really 2 times your amplitude if you're going from minimum to maximum. When I say height right there, I'm thinking from the midline. How high it goes, how low it goes from the midline. Okay. Period is going to be your length. Okay. So you'll use amplitude to do the vertical, you'll use period to do the horizontal. Okay. And that will help us construct what are all those labels that we would have on our frame. And then we're going to sketch the graph. So you decide, like, is it a sine graph? Is it a sine with a negative a? Is it a cosine graph? Is it a cosine with a negative a? That will kind of tell you where to plot those graphs. I would always be thinking about how those points that we plotted in those 4 things are related to the unit circle to help you out. So like it's not just a memorization of the shapes, but you understand why sine starts at 0, 0 and why cosine starts at 0, 1 in the unit circle. Okay. And these are 2 important pieces for your homework tonight. You'll sketch your graph, okay? And you'll be thinking about, is it positive or negative for A? And the other thing is, label the 5 critical points. So now you'll give them X, Y ordered pairs. Okay? Those are things that when you do your quiz and you turn in your problem set, those are things I'm going to be checking for. So I'm going to want to see on your quiz 5 points labeled for each graph. And same on the problem set. And then also we're going to practice doing domain and range. Nice thing is domain for both is pretty much always going to be all real numbers. Unless we put it in context of something, we would be all real numbers all the time. Okay, so let's do a graph. Y equals 3 times cosine 1/2 x. Do the work that you did yesterday. Find the amplitude. Find the period. Find the starting point. Lean to your partner sitting right next to you. Share your amplitude, period, and starting point. What do you guys get?
Well, yeah, like over 1/2. So like 9.
Wyatt, what's your amplitude? 4?
Oh, no, never mind. That's period.
Closer. What about amplitude?
3.
Yeah. Y equals A times cosine of bx minus c plus b, right? And amplitude is A, or the absolute value of A. So the amplitude is 3. What's your period, Jesus?
4 pi.
for pi. So I'm going to do the work up here, 2 pi divided by 1/2. We're not going to leave it like that. If you divide by 1/2, you're really multiplying by 2. So that is 2 pi times 2 over 1, which is 4 pi. Thank you, Jesus. And Joshua, what did you get for starting point?
I got 0, 0.
Not very exciting. Okay, 0, 0. Okay, so now we have those same things that we did yesterday, so nothing new right there. We are going to construct a frame. Let's see where can I put it right here. I'm going to draw a rectangle. I'm going to label my starting point 0, 0. Okay. I'm going to make my 8 little boxes. And so what I want to know is I want to know, like what's happening on the vertical part of my frame. Okay. So normally, like we know that sine or cosine, we just go up 1 and down 1. That's our range, -1 to 1. Okay. But Wyatt told us that the amplitude was 3. So what we want to do is we're looking at the y coordinate right here, which is 0. It should go up 3. So this line right here is 3. And it should also go down 3. So that's -3. So if you think about like -3 is going to be your lowest point, +3 is going to be your highest point, and the distance between -3 and 3 is 6. Half of that is 3, which is our amplitude. Okay, so you got to add it on top and the bottom. And then the other thing we want to do is label these markers with our period. So let's see, I think Jesus gave us period. He said it was 4 pi. So now we're looking at the x-coordinate of your starting point, which is 0. This works out really nicely for me. 0 plus 4 pi means this very last one is 4 pi, right? Okay, like this is 0 right here. And then we're going to 4 pi. So this is how I kind of think of it. From 0 to 4 pi, what's half of that? 2 pi. And so 0 plus 2 pi, this half mark is 2 pi. And what are the other marks? 1 and 3 pi, right? This one's pretty easy to split up into fourths. Okay. Now, you would have to think a little bit careful, like, let's say your starting point was not at 0. What if your starting point was shifted, like -pi/2? Then you've got to add 4 pi to -pi/2. And you got to think about where would it land. Then it wouldn't land at 4 pi. The period would be longer if it did. Okay. So be aware of that. And we've got everything labeled on our frame, so now we just go up and we look at, this is a cosine graph. We didn't make any comments about it being reflected, so it's cosine with a positive a. So you put your 5 critical points in the graph. Just cosine with positive a looks like. It starts at its maximum. The last thing you want to do on your actual frame is go through and label those points as ordered pairs. Okay? So you basically have everything labeled around the frame, putting the points down, not too terrible. So this point has an x value of 0 and a y value of 3. Here we've got an x value of pi and a y value of 0. Here we're at 2 pi and -3. 3 pi and 0, and then 4 pi and 3. And so I've labeled the 5 critical points. Even though you've labeled around the outside, I'm still checking for those 5 points labeled as ordered pairs. Does anybody have any questions about how I got those ordered pairs? Okay. Last thing we want to do, label domain and range. So domain, -infinity to infinity. As should be true for all sines and cosines, unless it's in some kind of like word problem, application problem, where a certain point it starts or stops. And then what's my range now?
-3 and 3.
-3, +3. Notice I'm using brackets. because it is actually at -3. There's a closed circle there. It's actually -1. And you just graph the. Now, one thing to think about just really quickly here is, how does that actually look if you compared it with the parent function? Like if we graph this on our graphing calculators, there are a few things that are changed, right? The amplitude is 3. So if we compared it to the parent function, it goes higher and lower than the parent function. So the waves are taller. Okay. The other thing that changed was the period. The period is no longer 2 pi. The period is now 4 pi. So are the waves stretched or shrink? Stretched out, right? The waves are kind of like more gradual, going higher and lower. Okay, so it takes longer for the period to happen. So we're not really going to see that part of it because ours are always going to be in this nice tidy box that we label. Okay, but it's something to think about. Okay, let's look at another one. Y equals 4 times sine of 2x minus pi over 2. So I'd like you to do the same thing that you did before, which is your work from yesterday. Could you please identify amplitude, starting point, period. Okay, lean over to that buddy sitting right next to you. Share your amplitude, period, and starting point. Okay, Stephen, can you give me amplitude? Mary Kate, can you give me period?
Pi.
Alright, this would be 2 pi over 2, which is pi. I agree. Okay, just so everybody knows that's the word for it. Eric, did you guys get a starting point?
I got -pi/4, 0.
-pi/4, comma 0. So let's look at that because when I was listening on conversations that were happening, probably starting point was the one that most people were like, oh, I'm not sure if I got a starting point. Okay, remember for the starting point you should do C over B. So we're thinking A times sine of bx minus c plus d. And so our C, notice how they're both subtraction here. So C is really pi over 2. Okay, so I'm thinking pi over 2. All over B, which is 2. You use that for the period, right? When you divide by 2, what are you really doing? Multiplying by the reciprocal, which the reciprocal of 2 is 1/2. So if you divide by 2, a whole number, now you're multiplying by 1 over 2, and that's where Eric gets the pi over 4. You had negative pi over 4 should be positive pi over 4. Okay, so, you know, C is kind of tricky, and then it works a lot like the H we always saw with other functions. It looks like the opposite of what it is. So when you see it looking like minus pi over 2, it's really positive pi over 2. Okay? Because it has a subtraction in the original problem. So I would change that to a positive pi over 4, and then D is 0. But otherwise, I agree with it. Okay, so let's go ahead and construct our frame. I'm going to mark my starting point, then I'm going to cut into my 8 pieces. And remember that for amplitudes, you are doing vertical work. So you are adding your amplitude to your y-coordinate of your starting point. So we had a vertical shift, so we're just going up 4 and down 4 from 0. So when I label those points at the top and the bottom, I'm going to get 4 and negative 4. In terms of the period, I'll have to watch out because I had a horizontal shift. It went right pi over 4 now. So when I add the period, which, who gave me the period? I can't remember. Mary Kate gave me the period. Pi, I have to add that onto pi over 4. Okay. So if I have a period of pi in between the first and the last point, where am I landing? What's pi over 4 plus pi? 5 pi over 4. 1 1/4. 5/4. To get my middle one, I might think about, instead of adding 2 pi, instead of adding pi, I'm adding half of pi. So I could think about what's pi over 4 plus pi over 2, or what's in between pi over 4 and 5 pi over 3. 5 pi over 4, 3 pi over 4. Thinking ahead, aren't I? Anyway, answers. What's in between pi over 4 and 3 pi over 4?
1.
What number is between 1/4 and 3/4? 2/4, which is 1/2. What number is between 3/4 and 5/4? 1, 4/4. If you add a 1/4 to a 1/4, you get a half. If you add a 1/4 to a half, you get 3/4. If you add a 1/4, you get a whole. And you add a 1/4, you get 5/4. Okay, so you got to do a little bit of fraction work. There's lots of ways for you to think about that. If you're having a hard time doing your horizontal work, by all means, stop in before after school real quick. And I'll kind of like ask you some questions and see what you're going to get. Okay. The next piece is just graphing. So you're thinking now about which shape you have. It is sine with a positive A. So I know I start at the starting point for the frame, and I go mountain high, valley low. Label my points. This will be pi over 4, 0, pi over 2, 4, and 3 pi over 4, 0, pi negative 4, and 5 pi over 4, 0. The work that you do at the beginning to properly label your frame pays off, because then your coordinates are no more work than just like listing out ordered pairs. So you've done all of the work for those coordinates. Last thing, do domain and range. I'll do them right up here at the top. That would be negative infinity to positive infinity for domain. This time my range will be what? What would be my range? Austin?
-4.
-4 to 4. Okay, so that's the basics of graphing, okay, constructing the frame. Probably the things I think that you'll have to spend the most time with are obviously going to be correctly identifying your starting point. If you get the starting point incorrect, then the rest of the graph is going to be labeled incorrectly from the get-go. Okay, so starting point is really important. And the other thing I think that most people have a hard time with are the horizontal distances in terms of like adding your period and then finding those sections. I always just think like, I'm going to add the full period, so where does it end? And then I start to think about like, I want to go halfway, so what is in the middle of those two? Okay, or you can actually do the mathematics work, and like if your period was pi, add pi over 2 to your starting point. Okay, and then if you are going to take half of a half, you'd be adding a fourth to that. So you'd add pi over 4 to that. Okay. So on your homework assignment for tonight, you have 4 required graphs. I'm going to want to see those tomorrow. Okay. And I would like for you to label the 5 critical points and also state the mean and range. Tomorrow I'll bring my dot camera so that we can put up the graphs on the board and you can actually like see if they look the same shape, and then I'll kind of point out like what are my numbers on the horizontal and vertical, or I can read off my critical points, and that way you'll be able to tell if I've done them correctly.